Welcome to another Mattermost Dev Talk. My name is Chris, and in this Dev Talk, we're going to be doing some refactoring by rewriting Go ASTs. In the Mattermost configuration structures, we have several fields that are represented by pointers to strings, booleans, or ints. We use pointers so that we can distinguish between the default 0 value of these fields and absent values if the field is not present in the JSON configuration file. The problem with this is it makes some of our initialization code a bit ugly. It's not possible in Go to get a pointer to a literal, so we've been separating the initialization for each field into two lines, one that allocates a new pointer to your built-in type, and one that actually does the assignment. In this dev talk, we're going to be adding some new functions, some helper functions, and replacing each of these lines with a line that looks something like this. So the first thing we're going to do is we're going to define our new functions for the built-in types. So we're going to create a new file over here, and these are going to be really simple. We're going to have new int. It's just going to return a pointer to the argument. We're going to have the same thing for 64-bit integers. We're going to have the same thing for strings. And we're going to have the same thing for booleans. There we go. Let's make sure to add our copyright header. And now we need to update all of our code to use these functions wherever possible. We can get a rough estimate of how many places in the code base we'll be replacing by searching for new open parentheses, because we don't really use new for much else. So let's get rid of our vendor results here. These are all of the instances we'll be replacing, and a few more that we won't be replacing. We could go through these by hand and replace each of them, but instead we're going to use AST rewriting. AST stands for Abstract Syntax Tree, and that is the representation that your source code files get turned into pretty early in the compilation stage. So, for example, this simple Hello World program will get parsed and turned into this AST, which consists of series of declarations, a function node with a name, a type, and a body. The body then goes on to contain a list of expressions within it. So as you can see, it's a tree that contains nodes that represent each entity or thing in our source code. Go has several libraries that make parsing source files and interacting with the AST really easy. And we're going to use those. And the end result is we're going to have a script that is going to take all of these instances of new and replace them with calls to our handy dandy new functions. So let's get started. Start a new script. There we go. So we're going to do this one package at a time. Let's just start with model for now. We'll add the rest later. And we'll create a fix function that'll run on each package and fix it. Now the first thing we need to do is we need to create a new file set and actually parse the source files. We need to add the parse comments flag just to make sure that when we do reassemble the source files, they include all of our original comments. And it's okay to just panic because this is a one-time use script. We don't have to worry about gracefully handling errors. Let's see, so far we've used /token /parser. Parse directory will return a dictionary of packages. In our case, all of our directories only contain one package. They might contain more than one if you do like black box testing, where your tests run in a separate package. But we'll just loop over them. And we're going to do this one file at a time. So for every file in the package, we're going to look at it. We're going to use the AST.inspect function to inspect every node in the AST for that file. Give ourselves some feedback here. So we need to return true. And we'll need to add the go/AST import. So there you have it, each file in our model directory. So now we need to figure out what we're looking for. We're going to be looking for statements that look like this. And in the AST, it's going to look like this. We're going to look for two back-to-back statements where the first one is an assignment, where the right-hand side is a call expression named new. And we're going to be looking for that sequence within a function declarations body or block statement. There are also a few other types of nodes we can find that sequence in, like case clauses and com clauses. So both of those types of nodes have a body member. We're going to look at that. So So let's start by just looking through the statements in each of these bodies and printing out the assignment statements. Oops. There we go. So we can see here, these are the assignment statements. Now we want to narrow this down a bit. So let's look for the ones where the right side is a call to new. There we go. That narrows it down a lot. We still have some here that we're not interested in, such as this. We're not replacing any calls to new with types like manifest or bytes.buffer. So let's look at the first argument. We're interested in string, int, int64, and bool. And that looks better. Okay, so when we encounter one of these, we're going to replace the call to new with call to a function. So that function will be determined by the type. Let's just go ahead and make a variable here to store that function when we figure out what it is. So the function will just be an AST expression. We need to create a new identity node. Where the name is based off of the type. And in the future, once we do packages outside of the model package, we'll actually need to make that a model.new, and model.new string, whatever. So if we're not looking in /model, we'll just go ahead and make that a selector expression, which is what the nodes for the dot notation are called. Model dot whatever. So that'll assign the function to be called to a new function here. Let's go ahead and store our assignment statement in a variable as well. And then we're going to start looking for the second line. So we're going to look for another assignment expression. Following the ones we just matched. We need to make sure that they are star expressions, meaning we're assigning to the value at a dereferenced pointer. And then if we do that, we're going to actually modify our original assignment. We're going to change the left-hand expression to the thing that was previously on the left side, except not dereferenced. On the right side, we're going to have a call expression, and this is going to call our function that we determined earlier with the right-hand side of this second line here. And that'll probably work. It looks like it should update our AST with the correct thing. So the last thing to do is actually write our modified files. So we're going to come down here to the end. After we do this, let's create a buffer. And that should do it. So let's see what happens. That is almost correct. We need to be deleting this line and not inserting this new line here. So fixing that new line is pretty easy. Right up here, we can just use the go/token/ file set API to merge the lines. that we're replacing. So that gets rid of the extra new lines. Now we need to get rid of this. So I think we're just going to create another list here. Then down here, we're gonna update the list to the new list. And let's see, right here, I'm gonna append these statements to the new list, skipping these old ones that we're deleting. So that looks like it'll do it. Can make sure our comments are still intact. Do a git diff numstat to make sure that we are adding half as many as we're removing. So all of these numbers should be exactly twice these. And go and add our other packages. So looks good. Let's do a quick sanity test. And we're ready to commit.